are two questions that need to be asked. First, what is light? A wave or an object? We know that light travels, so second question is, does light travel instantaneously or opposite at a finite speed which we can measure? Defined by international lighting vocabulary, in physics, the term light sometimes refers to electromagnetic radiation of any wavelength, whether visible or not. For the second question, not only astronomers, scientists devoted a lot of time on the measurement of the speed of light. Until the early modern period, it's still an unsolved question. The first record examination of this subject was in ancient Greece. Empedocles firstly claimed that the light has a finite speed. He insisted that the light was something in motion, and hence must take some time to travel. Aristotle argued, however, that light is due to the presence of something, but it is not a movement. Euclid and Ptolemy advanced the emission theory of vision, where light is emitted from the eye, thus enabling sight. In 1638, Galliano proposed an experiment to measure the speed of light by observing the time between when a lantern is lit and when it is seen from a hill a distance away. Galliano reasoned that he would be able to measure the speed of light, but he failed. Although he was unable to distinguish whether light travel was instantaneous or not, he concluded that if it were not, it must, anyhow, be rapid. Nearly 30 years later, Ole Christensen Romer, a Danish astronomer, performed the first quantitatively estimate of the speed of light. From the observation that the Jupiter's innermost moon Lo appeared to be shorter when the Earth was approaching Jupiter than when receding from it, he concluded that light travels at a finite speed, and estimated that it takes light 22 minutes to cross the diameters of Earth's orbit. As the image shows, the light emitted by Lo at point C is the last bit of light we will be able to see from it before the lunar eclipse begins. If light traveled infinitely fast, then someone at point G would get the light at the same time as someone at point F, and there would be no difference. But if the speed of light were finite, that last bit of emitted light would arrive at point G earlier than at point F. If we can determine the distance between point F and point G, and we can measure the time difference between when the moon plunges into shadow, which is at point C, then we can measure the speed of light. The first successful measurement of the speed of light is significant. According to Michael Fuller, UVA physics professor, the attempts to measure the speed of light played an important part in the development of the theory of special relativity, and indeed, the speed of light is central to the theory.